Hello, today we want to talk about image. Is image a very, very popular data in our daily life? Of course, everybody loves take photo, right? Everybody have tons of photos on our cell phone, right? So, image has been a very basic multimedia data, okay, compared to video. It's a kind of just one still, normally rectangle image, okay. But there are several other terms in computer science and how we can use different technology to present the color or the different scale size of the image, okay. So let's talk about it, shall we? The first is that our today's main character, main topic, image. Okay, I'm drawing something. Of course, if I later on capture, okay, do the screen capture, I can create a pretty image. Okay, so first, we know that the image, they are two different type, okay, but they look like basically use a rectangle, okay, rectangle to define the dimension, okay, the kind of canvas, okay, of your image. Okay, you can use, and this place is normally, okay, we use top left corner as our initial point, okay, and width and the height. And then we can subdivide the image, okay, kind of subdivide it as a lot of small element, okay. And each element we call it pixel. Okay, actually this is a quite interesting name, quite common, but it is actually from the two words, okay. Pixel is a picture element. Picture element. So pic, EL, kind of use X, I don't know, borrow this, kind of combine these two words. So picture element, okay, as a pixel. So the problem is that the picture or the image, normally we have not just a black and white. Yeah, it is sometimes we only have a black and white. If that's the case, only black and white, each pixel element only have maybe you use a 0 to represent black, and you use 1, this value, to represent white. If that's the case, black and white image or bi-level image, yeah, each pixel will occupy only 1 bit, isn't it? Right? Very simple, right? But if it's not only black and white, it's kind of gradually from the totally black to the totally white, but it's a kind of gradual change in lightness. in brightness. Okay, so for example, like 0 is a black, but the 255 is a white. Okay, but from here to here, you kind of still in we call a gray, but a different level of the gray. Okay, a little bit light, and more and more and more and more, and totally white. Yeah, this kind of representation we call it a kind of grayscale image. Okay, our traditional monochrome TV, yeah, we kind of use a grayscale, only lightness, only the brightness. Okay, still we can represent a lot, right? If that's the case, of course, each pixel require, we know from 0 to 255, there are 256 actually, right? Combinations. So let's in this case we require 8 bits. Okay, we require 8 bits to store for 1 pixel. Okay, so 1 pixel, 8 bits, which means 1 byte, right? Yeah, so in that case, of course, your image data size after digitize will be quite an amount, right? Okay, let's move on. But sometimes we want to take the beautiful scenery. There's a color in it, right? So if that's the case, you need to use we call a color model. Okay, color model to kind of mix the color together so that we can present very, very colorful image. Okay, nowadays we use RGB. Okay, RGB is a very fundamental common color model. Okay, for each component, we normally give a 8 bit. Okay. Oh, that's a lot. Okay, 8 bit for R, 8 bit, G, 8 bit, B, 8 bit. Okay, to represent the color information, which means for each component you can have a 0 to 255. Okay. Yeah, you encounter that in kind of programming, some high-level drawing function in JavaScript. You can assign this. Okay. So, and one last thing I would like to mention about this kind of image, we call what so far we are talking about this kind of image is we call a raster-based image. Okay, raster image, they use a pixel element, and according to its color complexity to describe the color. Okay, so let's move back to our previous topic. What do I want to say is in modern computers, sometimes we want to create a special effect. For example, you may want one image layer on top of the other, but kind of not completely cover on it. You want the underneath image could kind of see through from here, okay, which means the top one, the front one, need to be transparent, need to be kind of not 100% opaque, right? This is we call a alpha channel. Okay, in modern image processing tool, we will have this alpha channel. Wow. Okay, that is a brief, very brief introduction to the digital raster image. Okay, and actually there are another type of image I want to talk to you about. Okay, is we call a vector image. Okay, as opposed to raster image, use a pixel element to store each color. Vector image use a mathematical geometry, for example, line, or curve, kind of describe the shape of the image. So why do vector image use this approach? Okay, there is a very big issue in the raster image. When we want to zoom in the image or kind of enlarge the image, maybe 2 times bigger, you may find the raster image 10 times bigger. You will start to see some artifact because the pixel element has been enlarged 10 times. So very subtle kind of artifact we will easily to detect. Okay. To avoid this, you need to have an original source of image with a very high dimension, which means the resolution is extremely high. Of course, that would take a lot of disk space, or maybe your digital camera have a amazing sensor so that you can capture the super detail of the data. Okay, so on the other hand, vector image, because we use a math geometry to describe the shape, they can avoid this because every time you scale up or scale down the image, they recalculate. So this is the good part of the vector space. So, okay, so we have both. We need both because the vector image, nobody use that to express the beautiful tree scenery, because it's hard to describe the subtlety of the picture. Okay, which require not something that cannot be captured through the math. Okay, we need to describe the subtle change of the element just from capturing. So we need both. Okay, we actually need both. So as a computer scientist or the student who first delve into this programming journey, we need to know when should I use raster image and when should I use the vector image. Okay, they are kind of trade-off. It is not, okay, this is always better than the other, or this is always bad. Okay, no. Okay, so that's it. Okay, we will later on we will look at the wiki to see how wiki page talk about this 2 type of mainstream. Okay, the digital image. Okay, I'll see you next time. Bye bye.